There are three types of discontinuity. They are removable discontinuity, jump discontinuity, and asymptotic or infinite discontinuity. The removable discontinuity occurs when there is a hole in the graph of the function. To remove the discontinuity, redefine the function at the point of discontinuity. The jump discontinuity occurs when the graph of the function stops at one point and seems to jump to another point. In a jump discontinuity, the left hand and the right hand limits exist but are not equal. For asymptotic or infinite discontinuity, this occurs when at least one of the two limits is infinite. Now consider f of x equals 2x squared plus 11x plus 5 all over x plus 5. A while ago, we were able to determine that this function is discontinuous at x equals to negative 5. Okay, so this time we determine what kind of discontinuity would this graph or would this function have. Okay, so as you can see, using graphical method, you would be able to have this kind of graph in which x equals to negative 5 is not allowed because this function will have a denominator of negative 5. So graphically, we can trace this completely. However, we were interrupted by a hole or an shaded dot on this portion. Now, if we will evaluate the limit of 2x squared plus 11x plus 5 all over x plus 5 as x approaches to negative 5, remember that this function is a rational function. So we need to determine whether this is in the lowest term already. The limit of 2x squared plus 11x can be factored as 2x plus 1 times x plus 5. As you can see, we can cancel the denominator x plus 5. So simply, we will be evaluating 2x plus 1 as x approaches to negative 5. Now, take note here, 2x plus 1 is already a continuous function. It implies that we can remove the discontinuity of this function. Thus, we redefine the function at the point where the function is discontinuous. So we will have a removable discontinuity in this case. Now, in order to redefine the function, we have to have the constant function negative 9, where x is equal to negative 5. Hence, we can already say that f of x is continuous at any point on the graph. So that makes sense why this kind of discontinuity is called removable discontinuity. Okay, so let's have another example. Let's determine the type of discontinuity exhibited in f of x equals x squared minus 1 where x is less than 2 and x plus 2 where x is greater than or equal to 2. Now, using its graph, we would be able to see that if we trace the graph, okay, we will be interrupted by this hole, then jump to another point in order to trace the other part of the graph. So, in this case, we will have a jump discontinuity. We cannot remove the discontinuity in this kind of function. Now let's have example number 8. Determine the type of discontinuity exhibited in f of x equals 1 over x squared. Now graphically, we can see that as the value of x approaches to 0, the value of f of x approaches positive infinity. So by definition, we can conclude already that this graph is discontinuous, and the kind of discontinuity would be asymptotic or infinite discontinuity.